Hi, everyone. My name is Mani Gopavar. I am Chief Technology Officer and co-founder of Reconstruct. I'm also Associate Professor of Civil Engineering and Computer Science at the University of Illinois at Urbana-Champaign. What I would like to speak to you today is how you can tap into your existing data, the data that you have on every one of your job sites, all the way from design to images and videos you're capturing, and bring that together with artificial intelligence-driven methods to enable remote monitoring as it applies to construction phase of every built environment, as much as it has to do with the inspection of existing assets. Before I get into the technical conversation, I would like to share with you some statistics. Last few years have been really exciting years for construction. The value put in place has exceeded $1.4 trillion. This is the highest number that we've seen for 12 years from now. While this number is really great, still a substantial part of the money that we spend on construction goes into managing our resources, and specifically labor. And when it comes to how we are coordinating, how we're communicating, and trying to get the work done, there's a lot of room for improvement. So if you do the math in terms of numbers that are coming out from recent reports, you can actually see the gap that we have in today's construction productivity is roughly close to about $200 billion. If we can address that gap, that means more assets for owners that they will be able to build and operate. And for contractors, that means a higher margin for profit. While you have this gap of productivity, the COVID-19 situation has made a huge impact. Because of social distancing requirement that we have on many job sites and days away restricted or transferred away from the job site, the impact on our productivity has been even higher. What does it though mean for those of us who are engaged in construction? That means in most projects that we're involved in, projects are falling behind the schedule and are over budget. Dodge Data and Analytics a few years ago performed a survey, and their data shows that more than 50% of any typical commercial project that we're engaging falls behind the schedule and is over budget. Only less than 10% of these projects are actually finishing on time. If you start looking to mega projects, any project that's larger than $500 million, you would actually see that the situation is even worse. In fact, a majority of these projects are falling behind the schedule. Now, if you start thinking about these metrics for performance, all the way from a schedule to how you're managing the cost and budget, how we look into the quality of the finished product, safety and design, you can start surveying various stakeholders that engage in the project. And interestingly enough, Dodge Data Analytics performed that survey a few years ago. I had the opportunity of performing the same at ENR Future Tech recently, together with an owner representation. And we realized that among various metrics that matter to owners during construction, schedule is the most important one. It might be surprising to some of you. We all know design is extremely important. In fact, data shows if you spend $1 in design, you'd be able to save $7 in construction. So we have figured out ways by which we can manage the design. When it comes to safety, we rely on our contractor to manage that for us. Quality is whatever we see in our design in terms of the specifications or IFC drawings. Budget, we have all kinds of techniques when it comes to contracting to manage that. But the schedule is the most difficult one to manage. And that puts everyone at risk because every single day of delay on managing and operating your asset, that means your opportunity for generating revenue is lost. So for us to really understand what is the main root cause for projects that are falling behind the schedule or are being over budget, we need to go back to some of the basics of how we plan and execute our projects. Every project always starts with a plan. Then we go out in the field and try to implement that plan. And usually on a regular basis, whether that has to do weekly or daily, we're trying to coordinate that work, find the delta between what really happens in the field against what was promised, and see if we can bridge the gap by performing coordination and updating the basis of our schedule. Now, whether you're following conventional plan execution and monitoring cycle, or you're adopting and using lean construction principles, there are a number of problems that are actually contributing to failures in being able to successfully achieve the value of performing this cycle. Number one problem has to do with poorly planning the work. Over the past 2 decades, as an industry, we've significantly enhanced our capabilities of coming up with schedules. We're really good at planning out what needs to be done 3-4 months down the road or 2 years down the road. But when it comes to understanding how we can plan day-to-day operations or week-to-week operation, there's a lot of room for improvement. We've adopted lean practices, but these practices, as I said, require champions on the job site to make sure everybody is fully engaged in the process. And in the absence of these champions, a lot of projects go back to conventional practices, being retroactive to delays that happen on the job site, and singling out trade contractors in a coordination meeting in terms of how you're trying to resolve issues. Of course, we have better practices, but that better practice would require some form of support. Not only we have these plans, executing these plans is extremely difficult. Over the past 14 years, we've done a large number of surveys across many projects that we've been engaged in to really understand some of the root causes on why execution of plans are challenging. Our data shows there are many reasons. Many times work plans change in short term. Contractors are walking into space work areas not available to them. We underestimate productivity rates that is really desired for execution of a project. If you look into all these different reasons, 79% of them are preventable. All we need to do is to make sure project management actually has access to this actionable information on what is going wrong, what is potentially going wrong, so they can actually address these problems before they happen. The third problem that is contributing to this notion of delay and being over budget on project has to do with poor communication. Even in 2020, we rely on field engineers walk around job sites with 11x17 sheet and a highlighter to highlight how much work is being done. Sometimes we rely on our contractors to report that to us. There are field engineers sitting in our trailers processing that information, and usually they don't even trust that information. Management doesn't trust that information. So we wait for an entire week so we can actually have all stakeholders in the same OAC meeting, owner, architect, and contractor, and we ask contractors to stand up and color code how much work is being done. So from the time that the problem happens to the time that we really learn that that problem happened, we effectively lose 1 week of work. And this information is extremely hard to communicate. It stacks up, so it adds to complexity of being able to manage performance issues. And the last problem that has to do with this planning, monitoring, and control has to do with how we're reporting progress and how that information is being used as a base of a scheduling. In today's world, many of our schedulers, many of the people who are engaged in the planning process are not out in the field. So they're always missing that feedback of how much work really happens out in the field and using that as a basis of creating better, more reliable plans or revising an existing plan for an execution, for an ongoing project. So in the context of these problems, me and my team, we're really interested to see how we can tap into existing data that you have on your job site to address these issues. From one end, we've seen significant growth in adoption of building information modeling. We wanted to see how we can extend the value of these models that are already being coordinated. And every dollar you're spending on it, it's adding $7 of benefit or issues that you can catch ahead of time in construction, and using them as a basis of better planning, better monitoring, and being able to better resolve issues. So you can actually go ahead and tie these models against the schedule and create a timeline that will show you every single day who is expected to do what work in which location. So by tapping into existing data you have, design, and the schedule, it can form a reliable basis that can be used for planning and coordination purposes. Now, to address the gap of bringing that feedback from the job site and enabling a better communication, you already have visual data. What are we tapping to that? By visual data, I'm referring to images and videos you're already capturing. Images that many job sites are taking with their cell phones, time-lapse cameras that I bet every company who's participating in the Drastic Summit webinar is probably using one way of, these different ways of capturing visual data. 360 videos are extremely popular these days for indoors. You see people, mounting these cameras over their hard hat, walking around and documenting. Drones over the past 5 years have, dramatically transformed to be, a usual process of capturing images outdoors. In fact, construction industry is the #1 industry when it comes to the usage of drones. And many of you are already using laser scanning devices for quality control purposes. We wanted to see how we can tap into this growth in your visual data use that as a feedback to that plan, to the design model. So we can visualize what is there versus what should be there in the same place. Imagine you're sitting right now in Toronto and you have a project in Chicago where I'm calling in from. You basically go into this web-based platform and you're looking at a picture taken from the job site. The picture has been overlaid with the design information and is color-coded. Anyone looking at this picture immediately see what are the locations that are at risk, what are the locations that are behind the schedule, and what are the areas that are on the schedule. So being able to visualize what is there versus what should be there is extremely powerful. It has the potential to enable better planning. It has the potential to bring that information from the field back to the design and address many of these communication issues that are contributing to our project execution. Now, being able to perform this process by speaking about it is easy, but being able to do that requires a lot of fundamental capabilities that have now transformed itself into Reconstruct, a platform that took us roughly around 12 years of research and it's been commercial for close to about 4 years. Now, what it does is really takes in your existing data from that reality capture images and videos to the design information to the schedule and integrates all of them together to provide you with a single source of truth, one picture that speaks to every party who's engaged in the project. When you will have this visual command center, you can enable remote monitoring control. And because it uses different types of data, it enables a number of different workflows. For example, you can tap into your images and videos from drones, 360 cameras, and cell phones, and generate measurable walkthroughs on the job site. Imagine Google Street View and being able to walk around, going from one location to the other, and being able to measure and annotate the scene. That is the experience that we will be able to provide you. Then being able to use that for visual documentation addresses a lot of our problem. But once you add your design information, you'll be able to visualize what is there versus what should be there. So Reconstruct platform today has ability to digest 62 different file formats of design, all the way from Revit Navisworks and IFC files that you might be using to simple PDF documents that reflect 2D. So you can visualize what is there versus what should be there. And doing that in the context of a schedule, whether that's your master schedule from Primavera Cloud, whether it has to do with an Excel sheet that you're using for scheduling, can really transform your view and put everyone on the same page in terms of how much work is being done on the job site. You log into a web-based platform and the system would visualize the most up-to-date status of the job in a measurable form. There's a point cloud, there's an image in the back of the scene that is being overlaid with the design information. Design is tied to the schedule. So locations, work packages, tasks that are behind the schedule or on the schedule are being color-coded accordingly. Now, this system not only has ability to detect and track progress, has ability to learn patterns of performance. So it learns how various contractors on a given project are performing. Some start a slow ramp up toward the end of their activities. Some, we call them 10-80-10 contractors. They start slow, they ramp up halfway through, and they finish the task really strong. Our system has the ability to tap into artificial intelligence capabilities and learn these patterns of performance. So it can reliably predict the future, and it can highlight locations as it relates to your looking at the schedule that are exposed to potential risk for delay. So if your team starts taking an action on them, you'll be able to address the issues. Now that they can actually visualize what is there versus what should be there, you can also see this in terms of commitments that are being made in the context of the schedule. Here's a simple visual that shows you who does what work in which location every single day. There's a legend of the trades that you see on the lower left corner with colors. Those colors are reflected on the schedule. They're reflected on the model. You can see the reality and contrast that, automatically take off quantities and make sure every work is being properly coordinated. And it all means now you can start bringing this entire capability into a process and engage your entire team, whether they happen to be co-located in a coordination setting or happen to be a remote monitoring with COVID-19. In this case, what you're looking at is a project in St. Louis. This project was $150 million, higher as a structure, and you can see the superintendent is running the meeting by using these views in Reconstruct that highlight locations that are at risk. If you notice on that largest screen, there are two locations, one color-coded in red, one color-coded in orange. the system has predicted that these locations are at risk of being delayed. Delay that hasn't happened, but now you go into the meeting, every party from owner to contractor, sub, whoever is part of the meeting here can be part of the conversation and contribute to how we can improve reliability of the plan and tap off these delays before they happen on the job site. So in the context of that, I would like to break it down for you, this visual command center, into its components. One component is a very, very simple workflow, which is just walking around the job site or flying a drone, taking images and videos and generating measurable walkthroughs. You know, a lot of you in the audience have heard the term reality capture, which refers to documenting these photos and videos. I want to introduce a new term today, reality mapping. And what I mean by that is being able to map the job site in 2D and 3D using these images and videos. So let's see how it works. There are really two components to this. What happens out in the field, outdoors, and what really happens in indoor location. And you know, as I showed you in the process of capture, there's really not one capture solution that would fit all job sites. You would come across job sites that can fly drones, some job sites cannot. They would be using 360 cameras, or maybe there's a tower crane, let's say downtown Toronto, and you don't have ability to fly a drone. So what would you do? You could actually use one of these solar powered cameras from one of our partners. It's going to be mounted on the tower crane on the trolley that moves on the jib of the train, and he moves about the job, takes pictures. These pictures and videos taken with these platforms can provide you with two types of deliverables, 3D point cloud and mesh models, and two-dimensional orthophotos that can be contrasted against the design and form the basis of that remote progress monitoring. So let's see how this experience looks like. This is a recent project. In this case, the owner of the project is Oracle, and the contractor is Pepper Construction. This platform has been actively used for the entire duration of the project. This is close to the end of the project as what you're looking at here in this case. In the back of the scene, you see a large three-dimensional point cloud and a mesh. What you see on the lower left corner is a navigation map that shows you the map. The system has the ability to visualize all this data against that project timeline, that orange timeline that you see at the bottom of the screen. And if you start clicking on every location in the photograph, in the point cloud, it would bring the most relevant image to you. And on that image, you'll be able to perform measurement. So now your images have mapped the job set in 3D, and as you can see on the lower left corner in that navigation map in 2D, with ability to measure and document. So what does that mean for us in 2D? You know, in your projects, you have individuals that are more 3D oriented and superintendents that really want to rely on their IFC drawings issued for construction drawings and use them as a base of coordination. You can actually bring them into this platform and have them overlaid against the reality. So now you can see what is it that we want to do. Now your drawings can be as simple as site layout, or it can be, you know, a shop drawing associated with, let's say, placement of concrete. All that information is being visualized against the reality, so you'd be able to monitor the work, coordinate the work, and check for quality immediately. While I showed you a very simple job, one small building, this capability can actually scale. This is Microsoft campus project in California, and I had an opportunity of working on this with an owner out of California, out of Seattle, OAC Services, and we just presented this project at ENR Future Tech. This is a really large billion-dollar project, and with flying a drone over this job site, you can get full visibility to the owner for every location that's on the job site. You can click on every location you desire. The system will teleport you into that location, and we can dive into that image view. What you're looking at is an image overlaid on a point cloud with a navigation map. On the image, you can perform measurement, measure length, angles, areas, volumes, and track them over time, or start documenting issues. I see a safety concern here. I see a logistic item that I need to be communicating here, or a constructability concern. All of that can be mapped and documented. Now, when it gets to indoors, that's actually more exciting because oftentimes, you know, for smaller job sites, we can easily walk on the job site and really get a feel for what's happening. But indoor is more challenging because we don't have time to walk on every job site every day, nor our project managers have that. What if we can tap into a simple form of capture so we can map indoors and communicate that really fast? The platform and the methodology that's really picked up for us over the past 3 years is leveraging 360 cameras. These are $300, $400 cameras. You can buy them and, you know, place them over your hard hat and walk around. The beauty of these cameras is that it captures what is in front of you, left, right, top, bottom, all at the same time. These videos can be processed the same as drone pictures that I showed you before. And for indoors, they can provide two types of deliverables. 3D images that would look like a street view, Google Street View, at the same time color floor plan that can be mapped against the design information. There's no need for anyone to stop. You literally walk around the job site, videotaping, and the video gives you this ability to generate these models. So let's see how that experience looks like. Again, let's pick up another example. Imagine, I am, interested to realize, monitor what's really happening on a project that I have in downtown Vancouver. This happens to be the 16th floor of that project, and I'm dialing in from, Chicago. What I can do is I can go into that location and I can have this street view experience where on the ground, I see these small blue donuts. Every one of them is a frame extracted from the video. As I was navigating between these frames, you probably noticed a little bit of a point cloud. That's really what the system generates, which gives you ability to do measurement. Now, when you go into every one of these images, you would be able to measure length, areas, volumes, and track that over time. On the lower left corner, you see the navigation map. Navigation map is showing you a color floor plan. That floor plan and the experience that you have all generated from a single video using computer vision algorithms. If you load in your design information with PDF, you can actually do this visual walkthrough against that floor plan. You see these blue donuts on the lower left corner? That's really the base of our navigation. So you can go from one location against the other. Now, turning off these layers, you can kind of get a feel for point clouds. So some of you have seen laser scanning point clouds, or maybe for the grammetry engines, you can actually contrast this capability against those. The only thing that is extremely unique here is the ability to tap into 360 photos. Now, everything I showed you was actually in the three-dimensional scene. Now you're diving into a 2D view where you'll be able to get access to a color floor plan. All this information is downloadable, so you can take it back into your design information and use that as a basis of as-built record creation or updating the base of design or for tenant improvement jobs. You can always go back to the three-dimensional environment and be able to visualize, design, model against that reality. So you can jump into any image that you desire. The system will take you back to that image on this web-based platform. You'll be able to overlay BIM on top of it. Imagine augmented reality without wearing goggles. This model is entirely interactive, so you can click on it, you can hide components, and start contrasting against the design. So let's say you have an interest in performing a quick quality control on that drain pipe and the HVAC system that you're looking at. So we can go ahead and isolate these components, play around with the visibility that we have in the scene, and see that delta between design and reality, and immediately go ahead and measure that. This is entirely driven by data that is behind the model. So if any information is being embedded into your design information, that can be democratized and shared while it gives you the added value of performing quality control. So in this case, you see that quality issues being documented, which can form the basis of an issue, or you can actually even communicate that via text message with anyone who's part of your team. So now that I've shown you this capability of being able to map indoors and outdoors, what is really the value of doing that? What it really does is it generates a historical record for your ongoing projects. If you're an owner, it's documenting every one of your assets. If you're a contractor or you're a designer, it provides you with the ability to remotely log into every project and measure every dimension in a three-dimensional form. All that can also be mapped in a 2D. So if you're documenting issues, you can minimize that time that you spend at the interface of design and construction to address RFIs faster and better. And this also forms a basis for future projects because you can actually use this as a basis of repeat projects if you haven't, or if not, you'll be able to use this as a documentation for operation and maintenance of your existing buildings. So this is really the first workflow. The second workflow has to do with integration of that against the design, visualizing what is there versus what should be there. I've already shown you one example on that 16th floor of a building. Here's another example. Imagine you're walking into this mid-riser structure and you're looking at a steel structure, and immediately you'll be able to pull some of the work packages that are relevant to you and have them overlaid against the design. In this scene, you'd be able to perform measurement, measure any dimension you desire, open up all the issues that are documented in the platform, and figure out if you can address them and move on to your project to the next level. So what does it look like in terms of the experience? Imagine you're back into that project that I showed you with Oracle and Pepper, you'd be able to go inside the building and dial into any location that you desire. You look into the donuts on the ground. You can play around with the transparency. The entire data is filtered to the ground level, first floor. And now we can go ahead and overlay the design that is only relevant to what we want to be exploring. So now you can see what is there versus what should be there. This capability can also scale outdoors. The platform is, in sync with quite a few data management platforms. So the most recent design information can be brought into the platform. With a simple video capture on the ground, minute long, you will have a measurable experience, and the design information is overlaid. If you play around with the transparency and interaction, you can extract more information. So you can actually see, we can get access to the property information that's been brought into the design. And if you want to see underground utilities, you can actually play around with it. There's some number of algorithms used here to reason about what should be rendered over the image, what should not be rendered. So we just disactivated that, and now you can actually see underground utilities. This really gives you that view for every one of your fixed cameras. You can go into every image that you desire and immediately can see what was promised to be done versus the reality of what's happening on the job. So being able to visualize what is there versus what should be there adds a number of additional capabilities. It's an ideal opportunity to perform remote quality inspection. It doesn't really limit itself to commercial building projects. In fact, for a lot of our industrial projects, this makes a lot of sense. Imagine you have a project down in Houston and the fabrication yard is up in Halifax. What if you had the ability of mapping what is really happening in the fabrication yard, performing a quality control on that fabricated module for an oil and gas project, confirm that before it gets shipped to the job site. And once it's there, being able to visualize that against the design so we can verify the work before it gets installed. That obviously gives you ability to perform progress verification and faster responses for RFIs. Now the picture I'm showing you is from that Microsoft project. In this case, we want to offer owners with ability to access all their operation and maintenance data that's behind BIM. But in real world, a lot of owners struggle using BIM and model authoring platforms. So what you can do is you can actually hide that model, let them directly click on images, and you can see that pipe that's been exactly overlaid on the right location in the image, and extract all that O&M data that matters to you. This by itself can be that live record for the project. You no longer necessarily need to go back and update the base of BIM. That BIM integrated to your reality map can actually gives you that as-built recording capability. And obviously, O&M data can be integrated into it. So you would have a digital twin integrated with your building automation systems that you can use for operation and maintenance. Now, the last workflow had to do with production tracking, which is ability to integrate with a schedule. So I'm showing you an example of how this really looks. Imagine you've loaded in a master schedule into the project, and you're looking at a reality against that schedule. Every day, you can actually look into the model and see only those elements that are relevant to you, color-coded for you, whether it would show you what is expected to be placed on the job site versus what is being finished, or trade locations. All that can be visualized against reality. So now you can actually decide on constructability concerns, safety concerns, and revise the base of the plan. Contrasting the two gives you ability to understand progress, and tapping into that AI engine can color code locations that are at risk for being delayed. So now owners, contractors, and subs would all be on the same page in terms of what are the areas that are at risk for potential delay, and how do we tap off delay from happening on the site. That means you can go into every location you desire, whether you're looking at underground utilities, erection of the steel structure, whatever work package you're interested, you can expedite that payment application by quickly reviewing that with the owner. Being able to go into every single location and look into that location as color-coded and say, I'm looking at that location, I can clearly see that was the area that was expected to be done, and this is the area that's behind. So we can figure out how we can revise the plan according to that. So being able to bring schedule and the ability to compare them, map risk in the future, provides you with a completely new set of tools from a project execution perspective. You can use this platform for progress verification, for analyzing risk for potential delay, and expediting payment application. Many of our subs contractors on average are delayed by 2 to 3 months on their payment. Imagine being able to expedite that, and imagine being able to expedite the retainage. So there's a lot of opportunity of being able to tap into this during the construction phase. And of course, beyond construction, this offers you ability to go back and have a full historical record of what has happened and use that for liability purposes. So what does it all mean? It means now we can actually go ahead and close the loop that we have in project controls, bringing everyone on the same page of what is happening on the project. Our meetings can be proactive. You see an example of this. This is a project in Chicago. You can see the superintendent is running the meeting and is highlighting locations that are at risk. Foreman with the concrete contractors is standing up and is now being engaged in the conversation. Everyone in the meeting has incentive to be part of the conversation. And if you offer a team that is already great with actionable insight, they will be able to spend their time on revising the basis of a schedule and improving that performance that we desire to achieve. If you're able to work with this contractor and before having access to this actionable insight, average performance that they had every week was 46% of the task being done, and many tasks were being delayed and repeated. We were able to improve that performance to 70% in a frame of 6 weeks. In 6-week time, the team got used to the process of being able to tap into the actionable insight and being able to transform how we manage and communicate risk. So what does it all mean? That means you have access to your images, design information, and schedule. If you can bring them together in a visual command center, you can always have transparent views for every party that's engaged in the project. You can show them what is there versus what should be there. Everyone will be able to get access to the project. And that means even without COVID-19, you would be able to minimize direct money that we're spending on travel time. We've actually done quite a few case studies in Atlanta, in Seattle, and quite a few other places that demonstrate that close to about 50% of the travel time can be minimized by being able to have measurable walkthrough against the design. All of that in the context of COVID means even greater value. The second piece has to do with communication of risk to all parties that are engaged, being able to verify billing. If you have repeat job sites, this is a really great source for catching those production and productivity trends and using them as a basis of forecasting. You'd be able to use a platform for quality verification. And what that really means is if you proactively start using that, you can minimize the number of change orders and claims you're going to see with the subs. In a recent case study we performed with Wallbridge on a large car manufacturing plant in Michigan, we were able to demonstrate that every month, on average, we have ability to save close to about $20,000 by being able to make sure everybody's on the same page and approve design information before it's actually become problematic down in the field. And last component has to do with making sure that the project teams are on schedule. I already showed you some of the metrics from an ROI perspective at a project level, but at an individual level, superintendents and project managers, that means being able to faster document progress and being able to minimize the FTE cost and time associated with the documentation. And this comes also from another case study we performed with a car manufacturing project. So now I've shown you these capabilities, and that means every party that's engaged in the project will all be on the same page in terms of who does what working with location, how much progress has been made, and where the project risk is located at. Now, as you can see, a lot of capabilities that I've shown you today are relevant to construction, but immediately you may start thinking that, gosh, maybe there's a room for this to be expanded to our existing assets, and maybe we can use that for infrastructure inspection. In fact, that's exactly what happened. We started working on this in the construction process, and we received inbound requests for parties that are interested in using it for inspection. What is the problem with inspection? All that time, effort we're spending on making sure our existing assets are able to preserve to the specifications that they were designed for. And there are many pain points associated to that, how we are going about performing these inspections, the challenges of planning and logistics for these sites, and assessments that can be inconsistent from time to time. What if we tap into the power of these digital twins, reality models against the design, and using them for inspection? And in fact, that's exactly what we did. We've transformed this platform to give you ability to do inspection. And now this has been scaled to hundreds of projects around the world for bridges, existing buildings, tunnels that are being inspected using this platform. The process is pretty straightforward. Images captured with 360 cameras with drones are being uploaded, and they generate these three-dimensional models of the existing assets. So instead of you spending your field in the field performing inspection, you can be sitting at the office, click on any location that you desire, and the system would immediately jump you into the most relevant image, whether that's the under the bridge deck view that you desire to see, and see cracks or spallings that are as small as 0.1 millimeter, measure them, and communicate them. In fact, this is been used so much that we've had the opportunity of working with the Japanese Ministry of Infrastructure, Transport, and Tourism, MLIT, and now this workflow is part of the national guideline for bridge inspection in the country of Japan. I don't mean to get into the details here, but what it all means is you can upload your drone images. The drone images or 360 images would automatically generate these visual models. You can perform your inspection virtually. Everything would be documented for you. And then with the push of a button, forms that are relevant to inspection, in this case, Form 9 and Form 10 in MLIT guideline, can be automatically generated. All that data is being securely stored and hosted on a cloud-based platform, which can be used for future inspection as a reference. So in the context of that, there are quite a few things that we've worked on. But I'm going to stop there, and if anyone had any question, I'd be happy to answer. Oftentimes, when we speak about visual command center computer vision systems, people say, so what is really happening out that is out there 5 years from today? So what's really cooking in that R&D kitchen? At the University of Illinois, we've been working on the next generation of these solutions, specifically associated with a number of problems. One is to automatically track progress. And I'll show you some examples, being able to color code green and red. Doing this problem automatically, as opposed to relying on users to provide input through phone apps or maybe through the web-based platform, is not straightforward. We've actually worked on quite a few machine learning algorithms, but in reality, when you put them into practice, the average detection accuracies that we see is roughly around 83%. I thought I should share this number and speak about it because there's a lot of conversation happening at Drastic Summit and many other conferences on automated progress monitoring. And I want to show you the state of the science. What is possible to be automatically detected from the job? And you may say, why can we not do any better? What does that 82% mean? That means a lot of these methods, like the one that I've worked on, rely on reasoning about geometry. Do I see something out in the field, and can I contrast it against the design? The problem is oftentimes that can be problematic. If you're working on concrete placement operations, you may be able to detect concrete, but for you to be able to reason about progress for this system, it needs to be able to differentiate between form work and concrete. And as you can see, a system like the one I worked on creates a false positive. Form work is being detected as work complete. And there are many other cases that elements are being severely occluded. We don't have proper visibility to them, and we don't have any opportunity of detecting them and reporting back properly. If you want to know what is really the most problematic basic science problem that has not been solved today, is really that ability of detecting materials and geometry from pictures. I mean, pick a simple foundation wall. If you want to be statusing that foundation wall, you need to be able to have a system that can differentiate form work from placement of concrete, from finishes that we use, to waterproofing insulation, to backfilling or cladding that you have, right? And without these systems, we may not be able to automatically status the job site properly. So over the past 5 years at the University of Illinois, we've been working on a number of deep learning algorithms. Deep learning is a body of machine learning and AI methods. And we've been able to expand the body of knowledge and being able to bring these solutions closer to the practice. And that means, roughly getting to numbers that will be closer to 90%. With scale that we've seen with the data that's being captured at Reconstruct and many other platforms that are out in the market, we now have ability to scale these methods to the to the scale that matters. So I would say next year in 2021, you should be expecting some of these methods to be graduating from academic work and be really offered as part of our startup and technology companies. Now, oftentimes when I get into this conversation, people immediately ask, so how am I going to do the capture? Am I supposed to be hiring someone to fly that drone for me? Is there a way to automate that? And in fact, there are methods of automation. You can rely on drones. Drones have ability to automatically monitor the work for you. The more problematic piece for those of us who are in the US is Federal Aviation Administration, because they have restrictions for line of sight, and that applies to many projects in Canada too. So we've been working on methods that, provided with a flight plan, can make an assessment on how complete and accurate a flight plan can be. And if we can actually feed that into the drone. So the moment that FAA relaxes these constraints, we will be able to imagine the following use case. Imagine the 4D beam model plus a schedule that I showed you being used as a basis of planning where the drone needs to fly to take the pictures for you. Then being able to visualize all that in the context of a web interface like the one that you're looking at, make changes to your plan before the drone flies. So now, once you've confirmed that you have the right plan for execution of the image capture, the drone can take off autonomously, go to the right locations for you, take the most informative images and viewpoints that are relevant for automated progress monitoring, and then color code the model to make sure progress is being properly statused. So again, fully autonomous workflow of a drone flying, performing inspection, downloading the images, in addition to the analytics that I showed you. That will be the future on outdoor visual data capture. And people say, would you be able to do this with ground robots? I never thought that in 5 years from the time I started working on this would be some form of a solution that the industry would be interested in. But in fact, there are many companies that have interacted with us showing interest on using some form of a platform for robotics. I don't work in the area of robotics. I only work on operating systems and visual detection capabilities that run on these systems. So what we decided to do is to really create something that resembles Roomba, the vacuum cleaning device. What if there's a 360 camera mounted on that platform and a superintendent with a joystick navigate that for you on the job site? We would map the scene, and then we would automatically learn how we can navigate through the site every night when the workers have left the job site, so we can map the job site, assess that for quality, and make sure the foreman, superintendent who go back to the job site the day after, they have the most recent information. This platform is ready for demonstration at Oracle Industries Innovation Lab in Chicago. So if you ever had interest, we'd be happy to take you there and demonstrate that to you. While we were working on that project, Boston Dynamics became a partner to us, and they also brought their Spot robot, which is equipped with Faro laser scanning devices. Same process. What I showed you before was driven by a 360 camera mounted on a very inexpensive platform. This is a really sophisticated platform with strong capability, which many of our partners are currently using it in 2020 for capturing their data on their job site. Now, another component that's really exciting is prescriptive data analytics. Everything I've shown you is really predicting risk for potential delay. But oftentimes when we speak about this with superintendents and project managers, they come back to us and say, well, gosh, that's great that you guys can show top 3, top 5 problems on the job site. Can you also provide me with your recommendation on how the plan should be revised? It's easy to say that, but being able to learn that, is a work of science. So we've been working on a number of machine learning and natural language processing capabilities that learns best practices from your historical schedule data, learns that knowledge that's been accumulated in planners and schedulers for many years, and it tries to replicate that by offering best recommendations learned over thousands of schedules that have been accumulated in the system. So again, this is another component of R&D that's happening in this space that learns these best practices. Now, the other aspect of it, on the entire opposite side of the spectrum, has to do with the visual data. What if we tap into the videos and images that we have so we can understand safety, occupational health of our workers? So we've been working on a number of these capabilities with a company called NVIDIA that offers graphic cards. So we've been coming up with new methods that live from the feed of the video can detect and track workers' body posture. And that information can be used as a basis of creating OSHA compliant reports from a safety perspective, occupational health, or even using that as a basis of assessing work that needs to be done. So let me just show you an example of that. Videos can be processed, and machine learning algorithms would have capability of detecting and tracking workers, the type of tools they're using, their body posture, and a sequence of activities. Performing activity analysis from the video with the consent of the workers for the workers. So what does it mean? That means we can actually use this in our first round of studies with a lot of our superintendents already do this type of task, meaning they get together with the team, they come with a plan on how they're going to do a repetitive task, and they try to refine that over time. Let's imagine we can take away that time-consuming this aspect of figuring out how we have to do that study and offer analytics. I'm going to expedite it here. So you can actually see a pie chart that shows you how much of the time is waiting, how much of the time is travel. So we can figure out and benchmark productivity across every type of work that we do and equip our superintendents with information on how the basis of that can be improved. So I showed you two parts really in my presentation. Part one, that was all commercial grade solutions that can be used today when it comes to AI and digital twins. And part two, that I showed you more what is really happening in R&D. This R&D capability has scaled. We've recently received awards from National Science Foundation and Illinois Discovery Partners Institute to establish the first National Institute for AI in Construction. We have 40 industry members from Turner, Mortensen, DPR, Skanska, as construction companies, to owners from Microsoft, Amazon, OAC Services, Facebook, to designers from SOM, Jacobs, AECOM, just naming a few. We have 10 faculty members across the University of Illinois and Carnegie Mellon, and also 2 universities from outside the US, Waterloo from Canada, and also ETH Zurich from Europe, that are also external members of this Institute for AI for Construction. We anticipate performing 4 workshops. These workshops will start from January, and if anyone is interested and passionate about more R&D in AI and its application for construction, we'd love to have you as part of our conversation. If you have any interest in what I presented to you for leveraging your digital twins and AI for progress monitoring, or on this type of research, that's my contact information. And with that, I would like to open up for questions. Thank you.